Morning grade 7, happy Monday to you. I hope you had a good weekend, whatever the weather might have been like. Today we're going to talk about angle relationships. So you've noticed that the last few days I've had you watch videos online that someone else made, then we did a lesson in our textbook, then on Friday I had you watch a video online again. Basically because there's a lot of information to cover, I'm trying to give you two different opportunities to learn it. So this is a little bit of review from the video you watched on Friday, but it's more connected to our textbook. The first thing that I wanted to do though is review this type of diagram. There was a few questions that I had from our lesson on Thursday that you marked on Friday, just the difference between line and line segments and things like that. So I just wanted to point out a few things to you. So first of all, let's say I want to name a line on my diagram here. So let's say I want to name this line right here. Okay, so I can name that in a couple different ways. I can name it as line CJ. Switch to this pen because it works a little bit better. So I can name it as line CJ, where I put arrows to show that isn't a line. It goes on for forever in both directions. But I could also name this same line by calling it CP. It's still naming the same line because the way that I name a line is simply by using 2 points on that line. I could call it CD, I could call it PJ or DJ. It's basically just telling you, find those 2 points and whatever line they're on, that's the line we're talking about. But I can also name CJ just as a line segment. So you'll notice that CJ, I can treat it as a line by using the 2 points, or I can treat it as a line segment by just looking at the dots. Okay, so I can call it CJ like that. So all lines can also be called line segments. But you'll notice over here that I have a line segment. This cannot be called a line. It does not have arrows going on for forever. So this one I would just call it LU as a line segment. Remember, I can also switch the order. It does not matter with lines and line segments. If I want to switch the order, that's totally fine. And let's talk for a second about rays. So rays, the order does matter a little bit more. Typically, when I'm talking about a ray, so let's say I'm going to do this one right here. I'm going to call this array PC. So I start at P and I go out all the way to C. But I could also call it DC. Start at D and go out. Okay? So you'll notice that this line here, I was able to call it a bunch of different things. I called it a line segment, and as well, I called it array. So I just want to review that with you, that there's a lot of different ways of looking at these things. All right, let's take a look at complementary angles. So complementary, you just need to remember that complementary angles are two angles that add up to 90 degrees. You should remember from grade 6 or grade 5 that this symbol over here shows you that it is a right angle. A right angle is 90 degrees. So if I know that these two angles that I'm looking at over here, X and 62 degrees, are complementary, I know that together they add up to 90 degrees. If I'm given one of the angles, I can easily find what the other angle is by doing 90 take away 62. So I can go like this, and I get 28 degrees. So I know that angle X is 28 degrees. If you want, which I'm guessing probably a lot of you don't want, you could also think of this algebraically. You could think to yourself, 90 degrees equals X, oops, that's not an X, X plus 62. Then you could get X by itself and subtract 62 from both sides. Plus 62 minus 62. And you would end up with X equals 28 degrees. Again, you don't have to do it that way. I just wanted to show you how algebra applies in this type of situation. So complementary, we're talking about right angles, two angles that together equal a right angle or equal 90 degrees. Now let's take a look at this diagram here. So here we have a straight angle. Remember, a straight angle is one we often forget about. It's 180 degrees. So you'll notice these arrows here. You could think of them all together. From one end to the other, we have 180 degrees. So supplementary angles are two angles that together equal 180 degrees. Another way to think about that is by calling it a linear pair. A linear pair is simply two angles that are adjacent. Adjacent just means they're beside each other, that make a straight line. So if they make a straight line, they've also made a straight angle. So then we can call them supplementary. So supplementary means they add up to 180 degrees. So just like before, if you know what one of the angles is, you can do 180, take away 45, and you would get 35 degrees. Make sure in your written work that you're not forgetting the degrees symbol. Okay, so basically I wanted to show you up here, straight angle and linear pair and supplementary are really all talking about the same thing. All right, let's go to the next one. So in the video you watched on Friday, it often talked about opposite angles. Another word for that is vertical angles. So vertical angles are formed simply when we have two lines that cross over each other. Now what you know about vertical angles is that, or opposite angles, is that the opposite angles are equal to each other. So if I have 76 degrees over here, I know that directly opposite it, I also have 76 degrees. Now, if I think back to my information from the slide before with supplementary angles, I can also figure out what x is, because I can look over here and I can think to myself, here's a straight angle. Notice that this angle and this angle together would be supplementary. It's a linear pair. Together they'll equal 180 degrees. So I can figure out what x is by doing 180, take away 76, and I would get 104 degrees. So I know that x is 104 degrees. Now I could think along the same lines, and I could think again about this being a straight angle over here and 76 and z together making 140 degrees. Or I can think about the fact that 140 degrees, or x, is a vertical angle or an opposite angle with z. Okay, so you have to start to be able to recognize these opposite angles when you're trying to solve different problems to figure out how big an angle is. Okay, so here we have two parallel lines. They're going in the same direction. They'll never cross each other. And they are crossed over by another line. So they're crossed by this line, and we call this line a transversal. So a transversal is just a fancy word for saying it's a line that crosses over two or more lines. So that's all a transversal is. But what a transversal does is it gives us a bunch of different angles that we can use to figure out the measurement of different angles. So the first thing we have is corresponding angles. Corresponding angles are congruent angles in matching positions. So if you take a look over here, switch to green, if I look at number 1 and number 7, those are corresponding angles. They're in matching positions on my diagram. You can almost picture this line over here sliding right up to over here, and 1 and 7 would match up as corresponding angles. That means that 2 and 8 would also be corresponding or equal. 6 and 1 are corresponding, and 5 and 3 are corresponding. So corresponding angles are ones that match because they're just in the same position. Okay, that's corresponding. Now let's talk about alternate interior angles. So alternate, what you can do is you can think of alternate as being opposite. Then you can think of interior as being on the inside. So alternate interior angles are also congruent. Remember that congruent means they are the same angle, the same measurement. So here, 8 and 1 are examples of alternate interior angles. They're on the opposite side from each other, and they're also on the inside of my parallel lines. They're alternate interior angles. 5 and 1 are also alternate interior angles. They are equal, okay? Finally, we have alternate exterior angles. So again, alternate needs to be opposite, but then they're on the exterior or the outside of the parallel lines. Sometimes people talk about cleaning up or painting the exterior of their house. That means it's the outside. So basically, all this information helps you solve different angles and figure out how much each angle is. So let's try and apply that to a problem over here. So this is not a great picture because not all the lines are properly labeled in terms of angles and things like that, but it gives us enough information to figure out what different things are. So the first thing I can do is I can actually start with 74 degrees and think about what I know about opposite angles or vertical angles. So, oh, that's not what I want. What happened to my highlighter? Oh, there it is. It's orange. I never make it orange. Sorry. So here we have 74 degrees. Its opposite angle is y. So I can write down over here, I know that y is also 74 degrees. Then I can do a couple of different things. I could look for corresponding angles. So I could picture that right over here, if I were to slide up this line, I could find a corresponding angle. So I could know that this is also 74 degrees. But if you think about the last slide, we talked about alternate exterior angles, and I could notice that this is on the opposite side of up here, and they're on the exterior. So I also know that those are equal. I can think about opposite or alternate interior angles and know that this is also 74 degrees. So there's different ways to get at the same piece of information that all of these angles are 74 degrees. Then I'm left with Z. Well, Z, I can look at Z in my original 74 degrees, and I can think about supplementary angles. And I can do 180, take away 74, and I would get 106 degrees. So then if I want, I can just think, well, opposite angle, it's 106 degrees up here. Then I could think, complementary or corresponding angles. I could slide this line up. This would also be 106 degrees. Or I could think that really it's an alternate exterior angle. And then I can think over here about an alternate interior angle. So there's lots of different ways to figure out the same piece of information. Obviously, it gets more complicated if you're working with a diagram that has multiple things going on, but sometimes you have to imagine that one of the lines is gone to really truly be able to see the angles. So I just want to quickly review a few things for your assignment, just to give you a heads up about the different questions you're going to do. So for numbers 1 through 8, you're given 2 different pairs of angles, and you need to decide what types of pairs are they. Are they both obtuse pairs, bigger than 90 but smaller than 180? Are they supplementary? Do those 2 pairs together equal 180? Questions like that. Then numbers 9 through 12, you're doing true or false. You really need to think about and understand the vocabulary in order to understand what it's asking you. For example, number 9 says, the complement of an acute angle is obtuse. The complement of an acute angle is obtuse. So you need to understand what acute means, what obtuse means, and what complement means. Number 13, you're finding the measures of the angles, similar to what I just did on the previous slide. It gives you one piece of information, and then you figure out what all the other angles measure. And then numbers 14 to 18, they give you angle pairs, and you are telling me what kind of pairs are they. Are they alternate interior? Are they supplementary? Are they vertical angles or opposite angles? Are they corresponding angles? So that's just a little bit of an overview of your lesson. It looks like a lot of questions, but they should be pretty straightforward and not a lot for you to write down. As always, feel free to ask me if you have any questions. I hope you have a great